Alright, so welcome to the second lecture on exponents. So this time let's take a look at division. So in the last one we looked at multiplication, so in this one we looked at division. So let's start again with an example. Let's say you had 8 divided by 2. Now very easily we can write down the answer to this as 4. And of course, pause and ask yourself, why is that 4? How does that happen? Right? So 8 really is 2 times 2 times 2. And here we have the 2 on the bottom. And what you're really doing is you're cancelling one of these for one of these. And you get yourself your 4. Let's take a look at another problem with numbers. Let's say you had 75 divided by 25. So you could think of this as 25 times 3, and then on the bottom you have 25, and then you can cancel one of these with the 25, and you get yourself your 3. So what happens if we had letters, right? So what if we had x divided by 1x? So if you follow this example on the left, then it must mean that one of these will cancel one of these and give us x times x, or x squared. Likewise, we could think of this as x times y, and we divide by x, and we can cancel those, and we get ourselves y. Let's do another example. What if we had let's look at 75 another way. Let's say this problem 75 over 25. Let's look at it another way. So let's break this down as 5. Well, it is 25 times 3. That's correct. Right? But let's break down the 25 as 5, 5, and 3. And then over here 5 and 5. Now these two 5s cancel, giving you 3. So if we were to do a problem with letters, well, that would be like saying x, x, y divided by x, x. That gives me y. Right? Let's do one more, and this time let's take 125 and divide by 25, right? And see if you can see a pattern. So again, let's break this down in terms of 5. 125 is 25 times 5, which is equal to 5, 5, and 5. And in the denominator, you have 25, which is 2 5s. And you get just plain old 5. Right? And then if you did the same version of it in letters, that would be like having x, x, x divided by x and x. And then you're getting yourself just x. Now a couple of things should come out from these two. So let's take a look at this situation. Well, actually, let's start with this situation and see if we can see a pattern to this, right? So over here we had x to the third, right? That's what this is, divided by x to the second. That's what this is. And the answer became 1. So it almost seems, it's not almost, it's the truth, it almost seems like what we did to get the 1 was to go 3 minus 2. Does that work all the time? Well, I don't know. Let's try it out. Let's say we had 5 2s. 1, 2, 3, 4, 5. And then we had 3 2s. Well, that gives me 2 2s, right? Or 4. Or in other words, if I had x, 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 and x, and I divide this by x, 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 well, I get, if I cancel, I get x2, which is really x5 over x3, which is, you can see, is 5 minus 2, 5 minus 3, excuse me, 5 minus 3. So right now you're starting to see the division rule, right? And so the quotient rule for exponents, let me write this down. The quotient for exponents says the following: x to the m divided by x to the n is equal to x to the m minus n, right? There is a condition that says x can't be 0, which is obvious because you can't have a 0 in the denominator. There's also another rule that seems to come out of this. So if you look at this example right over here, this one is x squared y over x squared, and if we apply the quotient rule, really what we have is x2 minus 2, which is 0. This is 2 minus 2, but we don't see that. So what that's telling you is that x0 is 1. What we have here is a 1. x0 is 1. So that's another rule that we are starting to develop. So if you look at this one, for example, same deal. It's really x1 over x1 y, and if we apply the division quotient rule to that, what we really have is x0 y, and when you look at the answer over here on the left, there is no x0, so then that x0 part must be 1, right? And that also is a important rule, and the rule is the zero exponent rule, which says that anything to the 0th power is 1. So let me write that down. 0 exponent rule, right? 0 exponent rule says anything to the 0th power works out to be 1. Again, x cannot be 0. The base cannot be 0. So let's do a simple example of simplifying using the 3 rules that we have so far. So simplify. Let's say we had x to the 3rd divided by x to the 2nd times y to the 2nd divided by y to the 2nd times another x, right? So I'm going to work this problem. There's a couple of ways to work this problem, right? You could first do the division. So if I did that division using my quotient rule, I get x to the 3 minus 2. And again, if I did this division using my quotient rule, then I get y to the 2 minus 2. And then I still have this x sitting there. So what's in the denominator? Denominator is a 1. You don't have to write the 1, but I'm just showing you it's a 1. There's always a 1, sort of a placeholder right there, right? So that kind of became visible. It is important to know where these things end up. So when you apply this rule as the quotient rule suggests, the answer is in the numerator. All right. So what does this mean, right? So let's write this down. This is x to the 1. This is y to the 0, and this is x also to the 1. Now, what is y to the 0? We know anything to the 0th power is 1. So then this works out to be x1, 1, x1, or simply x1 times x1. Now that's multiplication, and we learned a product rule for multiplication in the last lecture. So we can now add these two and write the answer as x2. We could have done this problem another way as well. So second method for doing this problem, and the second method for doing this problem is to have multiplied the x's, so adding the exponents first. So you could have in the numerator, so you could have written this as x to the 4, y to the 2, x to the 2, y to the 2. and then done the division. So if I did this division, I get x to the 4 minus 2, and then if I do this division, I get y to the 2 minus 2, and then I see that this is x2, y0, but y0 is 1. So I get x2, the same answer. So it doesn't matter which way I do it, I get the same answer. Alright, so we'll keep exploring these rules. So you have 3 rules so far: the product rule, the quotient rule, and the zero exponent rule.